All right, taking a look at triangles and trigonometry. It sounds overwhelming, but it's really not. There's a couple words in here that you might know. Pythagorean triple, Pythagorean theorem, mean, inverse. There's a couple things in here that are you're building upon things you learned previously. Let's start with Pythagorean theorem. So we know that the legs are going to be A or B, and those are interchangeable. Just know that a leg is going to be A or it's going to be B. C is always going to be the hypotenuse. That's going to be opposite of your right angle. If you draw a little line through the corner of the right angle, you can see an arrow. The arrow will point to the hypotenuse every single time. So if you're wondering, where's the hypotenuse? The right angle is pointing at it. If there's no right angle, you don't have a right triangle, so there's not going to be a hypotenuse. Let's just substitute some numbers in here. 3, 4, 5. And this would be called a Pythagorean triple, or also a golden triangle, because 3 squared plus 4 squared equals 5 squared. And the reason that works out is because they're perfect squares. And whenever we talk about that, it would be a 3 by 3, a 4 by 4, and a 5 by 5. Whenever you put those together, you end up getting a right triangle. So what that would look like is 3 squared plus 4 squared equals 5 squared. Whenever you have all three pieces of information and you're solving Pythagorean theorem, if you simplify each piece and one side equals the other, it just means that you have a right triangle. For example, 9 plus 16 equals 25. 25 equals 25. We just proved that this was a right triangle. Later we'll get into finding missing pieces. This is kind of just some rules that if you have a right triangle with 30, 60, and 90, that if you know you have two of them, you already automatically know what the other one is. So you don't have to go through and solve the problem all the time. It's just a rule you can remember. It's the same thing with 45, 45, and 90. And if they're like this and they're not given 45, you know that both of them are 45. So when it comes to sine, cosine, and tangent, the things you have to remember are your hypotenuse. So wherever your angle is at, it doesn't have to be right here. It could be right here. Opposite, if the angle is up there, would be right here. Adjacent is the one that connects to it. So if this were the angle, this would be adjacent. And the reason that we know it's adjacent and not the hypotenuse is because you can draw the arrow and it points to the hypotenuse. So all we have to do is think, all right, where's the angle? Where's it pointing to? That would be the opposite. What's it connected to? It's connected to the hypotenuse and the opposite all the time. So what we're looking at is right here. That means that this one is adjacent and it's connected to the hypotenuse. So we have an angle and a side. And what this stuff is ratios that connect them together. So it's like you're putting pieces of the puzzle into these formulas. Like, how am I supposed to remember this? SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. So all you have to remember is SOHCAHTOA, and then do your best to remember hypotenuse opposite adjacent. That's it. So let's say that we're given this. All right, so this is the angle we were given. That means that this is adjacent, this is our hypotenuse, and this is opposite. So I'm just going to label them. And we know that we're doing this because it's a right triangle. We have the right angle. And it's pointing to our hypotenuse. So if you want to label them all like that, perfectly fine. So what we want to do is use something with the hypotenuse that's on bottom. That way we can kind of sort this all out. So we can solve for the opposite, and we can also solve for the adjacent. Notice that we're not going to be using tangent. Okay? So what we can do is, this is what this would look like. T is going to be the angle measure that you're given, which is 34. And then the opposite, we don't know. And the hypotenuse is 25. Okay? So let's go ahead and set up the other one, since we can. Cosine, the angle measure. I'm going to use A, and then 25. Here's what this looks like. You want to get rid of that divided by 25. So we're going to multiply both sides by 25. And once we get these answers, I'll explain what it did. So let's look at a calculator. How the heck do you type this in? What? So 34 degrees sine will give you that. Okay? So multiplying by 25 will give you about 14. So what we can do is say that our sine 34, so let's see, that was the opposite. Opposite is about 14 feet. Okay? Let's look at the cosine. 34 degrees cosine is that times 25, just like we have written, is about 20.7. So 20.7 feet. Now, also the rules that you can triple check to see if you're even on the right track is the legs have to be shorter than the hypotenuse. Check, check. Cool. So what sine and cosine allowed us to do is use these two pieces of information to find two side lengths of a triangle that we would not have been able to find otherwise. It's an interesting tool. So this one has the location of the degrees in the other angle. So I'm going to go ahead and circle this one. That means that this is opposite and this is adjacent. Okay, so I'm going to label that, and there's the hypotenuse. So let's go SOHCAHTOA. All right, here's a piece of advice. Whenever you're looking at these, go ahead and section them out. And let's talk about what piece you have. All right, so you have the degree measure, check. It's a right triangle, check. What information were you given? You were given the adjacent. Which one of these has an A at the end of it? TOA. So tangent, 83 degrees, equals opposite, which we don't know, over the adjacent, 300. Okay? This is where we can multiply by 300. Multiply by 300. I'm going to show you a non-example of when you sit there and go like, hold up, I must have messed up and chose the wrong one. You can set up all three if you want, but you know you can't set up sine because you don't have the opposite or the hypotenuse. So it'd only be cosine you'd be able to set up incorrectly. Let's go ahead and do this tangent, see what it comes out to be. All right, so 83 degrees tangent times 300, about 2,443. Okay, so what we were looking for was the opposite, 2,443 feet. Okay. Now, if you're trying to figure out what the hypotenuse could be, you could go ahead and do a squared plus b squared equals c squared and come up with an approximate answer. Here's what it would look like if we were trying to set something up and we didn't do it correctly the first time. So let's say that we didn't do tangent first and we did cosine first. Cosine says to have adjacent hypotenuse. So that would be 300 over h. That would put us into another bind. What we want to do is be able to get this variable by itself. Whenever it's on the bottom, we have to divide by it, which would do the inverse, which would mean we multiply it, and then we'd be cosine times h, and then equals 300, then we have another problem to solve. So, there is more to it, but I want us to be able to identify the pieces. All right, so it looks like we have an angle over here. That would mean opposite. This is the hypotenuse, and this is adjacent. Okay, so it looks like we were given a degree measure and adjacent. So which one has adjacent on the bottom? Tangent. Okay, so tangent 62 degrees, and we're looking for the opposite side with 45 degree on the adjacent, or 45 feet. So multiply by 45. That'll go away. We're going to be left with opposite equals tangent. Okay, so 62 degrees tangent, 62 degrees tangent times 45. About 84.6. What does that say? 83.6? 84.6. Okay. 84.6 feet. So that is how you'd set this up. Let's start there and see how far we can go. All right, so repeat this process over and over and over.